Hello everyone, reporting today for Fun Robotics Network, I'm Abbas, and with me here today is none other than Team 15167 Robo Troopers from Herndon, Virginia. They are coming into the Houston World Championship ranked second by total non-penalty OPR and are your Chesapeake Winning Alliance captain. They have one of the fastest robots I've seen this season, just really excellent control throughout the teleop period, autonomous, just absolutely everything. They're going to be an absolute powerhouse coming into the Houston World Championship, and I can't wait to learn more about their robot coming up on Behind the Bot. Alright, Robo Troopers, so I guess my first question for you is that your robot architecture is pretty unique, I would say. We haven't seen many other pivoting robots implemented like this with that super high, pivot point and things like that. Really only one or two other teams come to mind. What was the reasoning behind this architecture?
Near the start of the season, we kind of just were kind of strapped on time. So we reused a lot of the stuff from last season. So a very simple thing for us to do as just a prototype nearing the season was just to begin our robot with just a lift and then just use the same hang hooks that we used from last year for center stage with the pivot point for this arm. And that design ended up working very well for us. So we saw no reason to change it.
Okay, got it. And now talking about the intake itself, walk us through the current intake design you have. We'll talk about, different iterations throughout the season, but let's start with what you have now.
Okay, yeah. So for our intake, basically, so it has two rolling gecko wheels that are powered by axons. And then we also have this linkage here, which allows it to open up like a claw for depositing. And this is very beneficial because it gives us more margin of error for intaking in the autonomous period. And also because it deposits like a claw, we don't have to wait for these wheels to deposit the sample. And by the design of the linkage, it also makes sure that the servo does not get back driven so it doesn't get destroyed.
Got it, yeah. And as far as iterations go, was this whole claw wheel hybrid something you did from day one? Was it something you had to add later in the season? Walk me through that.
So we started with just the intake without the claw functionality, just the two rolling wheels, but we saw we were severely limited by the deposit speed. So that's why we added the linkage to make it function as a claw.
Yeah, and now talking about the intaking aspect of it rather than depositing, you guys are just near instant with your pickups just every single time. Is that sensorized, just a ton of driver practice? What goes into that?
It's a combination of both driver practice and the sensor. We have a color sensor that automatically retracts after we pick up sample.
Got it. And is it just retraction? Does it also start driving back, raising the lift, anything like that?
It just raises the arm so that it doesn't hit the bar when we're driving back, and it retracts this linkage.
Mm-hmm. And as far as control of your just entire end effector system goes, in teleop, how are you doing that? Like, do you have your inverse kinematics mapping like everything, or what do your drivers control when they're moving around with the robot?
So for this part, the arm, the linkage horizontal extension, and the this small differential arm, diffie arm at the end, we use inverse kinematics. So we have in teleop, we have two different horizontal extensions. Like one time, for example, we extend like this, and then once we pick up all the blocks near our side, we have another mode where we extend even further. And between that, we use inverse kinematics to make sure that the intake is the same height off the ground, both for our hover position so we can cross the bar and for the intaking position. And we use that to determine the angle of the arm, how much we extend this linkage, and what angle to put these two servos at.
Got it. Yeah, makes sense. Talking about your horizontal extension a bit, it looks very, very light. Walk me through the rails. Are those MGN7s, MGN5s? What's going on?
These are MGN9s. We have two of them cascaded like this, and they're driven by a chain that's powered by two servos, which drives this linkage.
Okay, so it's a linkage drive at the end of the day, but the linkage is just offset along the length of the slides, I guess. Is that correct?
Yeah.
Okay,
yeah.
Cool. And was that just kind of like a packaging decision? Like, why have that linkage start all the way out there?
It lets us keep the servos closer to the pivot point of the arm, which just helps the weight balance.
Got it. And talking about weight a little bit, it seems very natural and fluid. Like when you guys are pivoting your arm about, is there any counterbalancing going on? Like how is it so smooth?
Yeah, so we have two pretty large, I would say, counter springs that help with the pivoting of our arm. And these just let it so that the two servo-driven arm is able to hold it and just not run into like any power issues or not be able to lift it. And then for the sequences for the arm, they're just optimized a lot so that it doesn't tip the robot due to the high pivot point.
Okay, I see. And yeah, I'm hearing just like a servo after servo on your arm over there. So yeah, correct me if I'm wrong, but you don't have like the arm itself is not on another lift, is it? Or is it just the arm itself for all of the extension and everything?
The whole like arm extension and everything is all on the same thing.
Okay.
The same.
Okay, I see. And so all of that is motor powered, correct?
Yes, the lift is powered by 3 motors.
Okay, and is that, so the 3 motors there, was that just like putting in as much power as you can? Was that like you needed the 3 motors? What's going on there?
Yeah, so we originally had 2 435 RPM motors, but we saw they weren't running at their peak efficiency, and we weren't hitting the lift speed that we wanted to hit. So we added a 3rd motor, and that just essentially made our lift run faster.
Okay, I see. And counterspringing there, or no counterspringing needed?
Yes, we do have counterspringing on our lifts that we added after states, and this helps our lift extension speed as well.
Okay, so again, here you're just using like traditional linear springs, extension springs. And so how come you didn't go for like constant force springs or rubber bands or like elastic or anything like that?
So implementing a constant force spring on our lift would like require a lot of like design change, and we just didn't think that it was just worth the time and effort to do that compared to just regular extension springs.
I see. And I feel like I'm seeing a larger use of COTS parts on your guys' robot as compared to teams. I mean, we see teams that just like fully custom robots, but your robot is clearly very fast and works very well. How do you decide between when to use a COTS part and when to make something yourself?
So usually we do a lot of the prototyping and so just like early development with the COTS parts. And then if there's a need for it to be CNC'd, then we do it. Like for example, our hang hooks are CNC'd because we can't make this with COTS. COTS parts just give us a lot of modularity and a lot of freedom with like design changes.
Yeah, that makes a ton of sense. Now, talking about hang, you brought it up. Walk me through the hang procedure, the hang mechanisms. Is it just level 2? You got that level 3 hang now as well, going into Houston?
Yeah.
Talk about it.
So we do have a level 3 now. Essentially, these hang hooks lift up and we drive into the bar and they pull down. And then these hooks over here, they push down with a spring and then retract back onto the level 2 bar. And then after that happens, then we raise the lift again, and then our linkage pulls the level 3 bar so that the robot gets pulled into it. So these hang hooks are above the level 3 bar, and then we just pull the lift down, and then these beams just help the robot slide up.
Talking about software and autonomous a bit, going into Houston, obviously you guys are one of the best sample robots out there. What is that sample autonomous looking like?
I think we're gonna run a 7 sample at Houston. So I think that's what we're running, and it's an upgrade from states where we had 6 samples.
And is that vision based or color, like just pre-mapping and then using the color sensor to verify? How are you doing those extra samples?
Yeah, we have the limelight over here for vision, and we also have this headlight to assist with the vision.
I see. And are you using that limelight again in TeleUp at all, or it's just not really needed?
No, we don't use limelight on TeleUp.
Okay, got it. Now, another thing I want to ask you guys is about cycling in the low basket. You guys are one of the very few teams that fills up that high basket so fast that you end up cycling in the low basket. What do you think were like the biggest optimizations you made in your cycle time to get to that point?
So I would say that first of all, the intake is, as you know, very efficient, so it picks up very quickly. But I would say the automation after that, where it retracts and then automatically we have just one button to raise our slides and arm to the deposit position. That just makes it so that I have to press as few buttons as possible when I'm outtaking, and that just speeds it up a lot. So we don't have like multiple button presses and everything like that.
Yeah, of course, that makes sense. And as far as weighting, like weight distribution and things like that go, have you had any issues with tipping? If so, how have you addressed them?
We did have a little bit of issue with tipping, so we solved that by, well, it helped a lot by putting the battery at the back of the robot. But for the most part, we don't really like have any tip issues or even like the wheels lifting off the ground for the most part, because the arm sequence, how it moves, we spend a lot of time optimizing it with code.
I see. All right. And as far as specimens are concerned, are there anything you guys want to touch on there? Any aspects of your robot that really make specimen scoring very helpful or anything like that?
Well, since our like the design of our robot lets us that we don't have to turn around to like give us a sample to the human player, we can just pick up and then just let it rotate back and then deposit to the human player. I would say that saves time with specimens, but specimens is most likely going to be something that we're not going to be focusing on too much.
Yeah, that makes a lot of sense. All right, and I think the last question I have is concerning robot size. You guys are definitely on the larger width of robots, I would say, as compared to what I've seen this season. Was that an intentional decision? Did it just kind of come about? Walk me through that.
So having like a larger like robot base, it extends our wheelbase, which makes it less prone to tipping. That's one design aspect of it that helps a lot, and it makes it easier to package all of our parts.
Got it. Yeah, and as far as defense goes, do you envision yourself using this wider robot base, to kind of bully people out of the way or, keep your space in the submersible zone? Is that something you guys have been practicing with or not really?
That is actually something we've been practicing with, okay. And yeah.
Cool. All right, Robo Troopers. Well, thank you very much. I'm sure everyone is excited to see how you do in the Edison division, hopefully making it out, taking it all the way maybe. You guys have been absolutely fantastic this season, and thank you so much for this Behind the Bot. Reporting for Fun Robotics Network, I'm Abhas, and this is Team 15167, Robo Troopers.